This next type of word problem, known as work problems, I have my own way of doing, and I'm going to show you right now the generic setup that I use, and it's a little bit different than any books. I say fraction plus fraction equals 1, and basically we have two people working together to complete a job. The equals 1 refers to a completed job. I put the alone time down in the denominator. That's how long it would take each person to do the job working alone. And I put the together time up in the numerator. And sometimes someone gets a little extra time spent alone on the job. The together time or the actual time goes in the numerator, as you'll soon see. So here we go with this first problem. Fred can paint the house in 30 hours. Barney can paint the same house in 50 hours. How long if they worked together? So here we go. Fraction plus fraction equals 1. If you want to label this as F for Fred and B for Barney, go for it so you know whose fraction is whose. Fred can paint the house in 30 hours. That is an alone time, which I put down below, and Barney's alone time would be 50. How long would it take if they worked together? We don't know that, but they're working for the same amount of time, so that will be X, which we're solving for, and it will be the same for both people. Therefore, we can just solve this problem by multiplying through by the least common denominator, which is 150, and that gives us 5x plus 3x is equal to 150. Therefore, 8x is equal to 150. Therefore, x is going to equal 18.75 hours. These are not always going to be nice, clean solutions, and in fact, when you're dealing with these problems, they usually are not clean solutions. If this was a multiple choice test, they would probably give you some disguised answer just to see if you've never done these problems. They'd probably give you 80 hours as one solution. It's because they think, oh, working together, add their times together. They'd probably throw 40 hours in as a distractor also because you say, oh, let's average their time if they're working together. But if you really think about it, the answer has to be under 30 because Fred could do the job alone in 30 hours. Barney's help is only going to drop the time for the total job to be lower than 30. But they tend to, when multiple choice tests are given, throw out those distractor type of answers there to confuse you or see who hasn't studied the material before. In this next problem, we have Gus working twice as fast as Sid, and together, here's one of these together problems. So here we go, fraction plus fraction equals 1. There's my total job being done. This will be G for Gus, that'll be S for Sid, so I know what's going on. Now, Gus works twice as fast. Technically, that means that Sid's time is going to be double than whatever Gus's time, because if you think about it, if he works twice as fast, he's going to be half the amount of time. That can be a little bit tricky here. And they're working together for 4 hours. That's the together or actual time working. Now we're solving for x and 2x, their alone speeds. So here we go. Let's multiply through by the least common denominator of 2x, and doing this we will have 2's canceling, or x is canceling in the first fraction, so 2 times 4 is 8, plus 4 equals 2x, 12 equals 2x, and x is equal to 6 hours. Now x, we said, was in the Gus fraction, so that will be Gus's speed, and Sid's speed will be 2x, which will be 12 hours if working alone. Now I said normally these problems have messy answers, but here happens to be an exception to the rule where you happen to have clean answers for these problems. This next problem is only confusing because they throw extra information in. You have two machines working together to finish a job. The job is to produce 7,200 cans, but we're going to forget about that. Fraction plus fraction equals 1, a completed job. The newer machine alone, so we got a new machine and an old machine. I'll just put N for new, O for old. The new machine can do the job in 180 minutes. The old machine takes 360 minutes to complete the job. How long will it take them working together? Notice how 7,200 was only a distractor in this problem to confuse you. We're just going to multiply through by the least common denominator of 360 to get 2x plus x equals 360. 3x equals 360. Therefore, x equals 120 minutes, or if you want to write that as 2 hours, you can do so. So we have another clean problem, with a clean solution, I should say. Another problem with some extra numbers in here to confuse you. You've got a pool holding 540,000 liters of water. It's got 2 drainage pipes. We got to be careful here because we're going to be, instead of adding water and working together, the draining is going to be working against the pipe that's filling up the pool. So the first pipe alone can empty it in 225 minutes. Oh, we're not talking about filling and emptying. Both are emptying. So together, we want to know how long can they empty the pool. So this is actually fraction plus fraction equals 1. One drain can do this in 225 minutes. The other drain can do this in 150 minutes. How long working together? Notice that that 540,000 liters of water was just extra information, and draining had me confused for just half a second, but we managed to get through it. So we're going to multiply through by 450, which is the least common denominator, and that will give us 2x plus 3x equals 450. 5x is equal to 450, and therefore x is going to equal 90 minutes. In this last problem, we have an old computer and a new computer. One takes 4 times as long as the other, and 12 minutes for the two computers working together. So here we go. Fraction plus fraction equals 1. We have the older computer and the newer computer. It takes 4 times as long, so 4x for the older, x minutes for the newer, and 12 minutes is the together time that we're going to have there in the numerators, that they're actually working. So we're going to multiply through by the least common denominator, which is 4x. In the first fraction, that cancels out altogether, leaving 12. In the second fraction, the x's cancel, so we have 4 times 12, which is 48, equals 4x. 60 now is going to equal 4x, and x is then going to equal 15 minutes. Now, how long will it take the older computer to send out the email on its own? Always go back and see what they're looking for. The older computer took 4x, and that means 4 times 15, so that would be 60 minutes for the older computer to send these emails out on its own.